So, welcome to our first effort to make these podcasts in English. My name is Anders Olsén and I recently made 2 broadcasts on Swedish National Radio about sound quality loss that gave overwhelming positive reactions from a lot more listeners than expected. And that's actually the main reason for the start of Ino-Lab. Many suggested that the information and the remarkable knowledge of my expert guests ought to be internationally available. So, here we are. The discussions here, though, will not be a sparkling radio show for everyone, more of a pure, dry scientific source of knowledge for people with more or less professional connections to the matter. And, even unlikely, there may be some of you that do not know who my experts are. So, let's start with you, Lars. Lars Mossberg. Who are you?
Well, I've been a sound engineer for most of my life at the Swedish National Broadcasting Company. I've mixed a lot of radio programs. And in the beginning as a common engineer working with everyday radio production. But after a while, I think the quality was not enough. I want to examine how deep I could go for to understand what's happening in the chain, the radio technical chain from mixing desk to transmitter. So I started to examine how all these long chains of equipment affected the sound quality. So I've been working under different labels, research engineer, developing engineer, and so forth. Titles are not important for me to make a good understand why are the sound so bad if you compare it with the original. That was my point. And for me, it's important that sound created by a producer and a musician or whatever remain the same when it reaches the listener. That is very important. It shouldn't be altered on its way by crappy or interfering equipment. It doesn't matter if it's a long FM distributing chain or a DAB chain or a DVB chain or a satellite feed or what you want. You have to get the exactly the same sound as original. So the original sound could be different. It's not wrong with compressed sound or a lot of bass, or it's up to the producer. So I want to it's more like a short line from one point to another. And it's very difficult to do that because it's a lot of difficulties with the FM system and low bit rates in DAB and so on. So you have a lot of difficulties there.
And you really have a lot of long lines.
Yes, a lot of long lines.
Yeah, but you sort of noticed very early that it's not enough to do just at the microphone or an amplifier or a preamplifier. You have to see how they interact with each other in longer chains.
And in the analog time, there was maybe it would be 50 or 70 transformers and 50 line amplifiers in cascade, and then sure it was not exactly the same sound that's coming out. But when the digital sound was much easier, but was new problems with the digital sound. There was a too low bit rate resolution, and then it was dithering problems. So there was a new kind of problems.
You had to restart it all over again.
Absolutely.
Yeah.
But now we have a very good distribution. We have a very good resolution and archive and everything. But then it could be the quality is worse. It depends on the production. What's happening with the level and the loudest war problems we were talking about, and cascading, a lot of cascading with the low bitrate cascading in some equipment and so on.
But you also have been sort of respected force within the EBU organization, the European Broadcast
Yeah.
Organization, in researching these things in big studies and everything? So you sort of work with that kind of
absolutely.
things for 30
together
years.
with
Yeah.
my colleagues is very important because we have a different kind of specialists. So we have done a lot of listening tests, and my colleagues have done more in statistical and so on. And I've been responsible for the sound quality and how to prepare items and so on. So there's a lot of much people. It's not me, only me. It's a lot of very, very good people.
So, if we can say that you are a sound researcher on molecular level, we have Ingvar, who is a sound researcher on
Astronomic level.
No, I would say no, quantum mechanic level.
Or even smaller. Yeah. I don't know. Well, I started out as a radio listener, as I think very, very many musical interested people does. My very early memories of caring about music was listening to a radio, a few years old, and
Turning all the knobs, listening to all.
searching for everything, searching for interesting music mostly, but the weird sounds was interesting as well. Absolutely. And I didn't really, I maybe 4 or 5 years old, I didn't really understand what the radio was. I just loved listening to it and finding music, and it was like, of course, something almost magical, having sound coming out of a box. So I spent a lot of time listening to music and also playing music. I played the recorder, and later I became a cellist. And I wasn't all that technical interested. I spent some time fumbling around with electronics because it was easy. I didn't find it very interesting, but it made it possible to make a lot of machines that I thought I needed. I made an FM receiver.
Easy for you, you said, because you had a talent for it.
Yeah, not
You did quite complicated things at an early age, I've heard.
Well, I didn't have talent for much else. I think talents have a tendency to tilt, because when you have no talent in a lot of areas, you get a lot of time. So I made amplifiers and a lot of technical things. And in the early 70s, I thought I really needed a good hi-fi setup at home. So I went to the library and I tried to study as much as I could from books in the library, how the human hearing was working, to be able to, from the brochure information from the manufacturers, buy something as good as possible, or as good as I could afford. And I did, and I was super unimpressed with the result. It really was a crappy hi-fi setup that I had bought, even though according to the papers it should be very good. So I found that quite interesting, and I bought some measurement equipment, the measurement microphone and a generator and an oscilloscope, and I started to look at the equipment that I had to understand why it sounded that bad, really bad. And I found that there were so many different reasons. One reason, of course, was that the thing that you could read about human hearing was in such a high degree flawed. This was like in 1972 or 73, and it was like common knowledge that 3 dB was like the least audible timbral or level change, and it was very easy to show that most people could hear 0.1 dB change, which is 30 times less. So and on top of that, especially the loudspeakers in the hi-fi setup that I bought was really bad. It was claimed that they were hi-fi speakers according to the DIN norm 45500, and that means that they, within the frequency range, should be deviations less than plus minus 4 dB. 8 dB peak to peak, and the actual speaker, when I measured it, actually covered the whole paper, which is 50 dB high. So, I mean, naturally, most of the extreme was notches going down, but still, plus minus 25 dB is not a good frequency response. And it was quite common during that time that frequency responses from loudspeakers were pretty bad. Many loudspeaker manufacturers didn't really measure much, and the production processes was not good enough to produce results that were stable. Different loudspeakers from the same manufacturer, the same model, would still sound different. And well, anyway, my conclusion was that I could probably make a better loudspeaker. So I ended up an amateur loudspeaker designer, and I made a pair of loudspeakers, a three-way system, actually looking surprisingly like the KEF 105 and the Bowen-Wilkins 801 that came many years later. And I thought it was good enough. It had a frequency response within a few dB, and I thought that this is really nice because now I don't have to do any more loudspeakers ever.
But instead you sort of started some sort of research institute or what?
No, not really. I just enjoyed music. I know what you're thinking about, but that was a few years later. It was in the late 70s. In 77, I actually met a medical physician at some kind of a gala concert in the concert hall of Stockholm. And we started to talk basically about psychoacoustics and audiology.
Okay, what is psychoacoustics?
Well, audiology is like the physical properties and the cause to the hearing. So it describes how the hearing is working and how it could be damaged and the mechanical processes. And psychoacoustics is everything else that explains why we experience what we experience when we are listening.
Sort of the brain's interpretation of what the audiology feeds to us. Could you say that?
Yeah, it's more interwoven, but yeah, maybe you can say that. And when it comes to most popular parts of the psychoacoustics that are researched, then it's quite often related to how we perceive our environment, and especially how like stereophonic reproduction work. So it quite often it has a strong connection to hi-fi. So we decided there and then to start a research center. It was totally privately, no connection to the academic world, and I named it Audio Purus. Actually, Audio Purus X. IX was Innovative Experiments. Quite a silly name, but still. And so from that time, or actually 1 year later, and 11 years from that, I was working with trying to learn more about human hearing.
For 11 years?
Yeah. The first year, from 77 to 78, I actually did only one thing, and that was to make a loudspeaker that could be used as a tool, an acoustic tool to create any acoustic sound pressure with control. I mean, most loudspeakers has behaviors and artifacts that makes it difficult to know exactly what you are exposing a listener to. So I needed a very, very high precision instrument. It was never meant to be used as a hi-fi loudspeaker, but it was meant to be a research tool. So it had to be phase linear to be able to reproduce to a very high exactitude the sound pressure signature from any instrument. Not only the right balance between high and low frequencies, but the exact wave shape from the original instrument. Because one of the things that I wanted to study was our ability to hear like phase distortion, all pass filter functions. And to be able to do that, I need to have a source that can play musical sounds and every type of sounds that are not pre-distorted, which would happen if I use any normal loudspeaker. So I used 1 year between 77 and 78 to make that loudspeaker.
To even be able to start the research.
Yeah. Well, actually, I did I did start the research during that time because some of the aspects of the loudspeaker needed knowledge that I had to. So I kind of did it together. I started a little bit doing simple experiments that I needed to do to know how to make the loudspeaker.
But could one say that your great knowledge in mathematics, in physics and electronic constructions and everything made it that you sort of made all this in a very strict scientific manner?
Yes, I always make efforts to do everything very, very scientific, but actually the physics of loudspeakers is not all that complicated. You can, if you have a fundamental knowledge of physics, loudspeakers is just the thing that makes loudspeakers complicated is that they are not as easy to evaluate, because I mean, if you have an amplifier, you have an input and an output signal, and the reproduction is perfect if the output mimics the input. It's very, very easy to explain. The loudspeaker is much more complex, even though it's a simple mechanical system. It have one input, but it have infinite number of outputs, because you have infinite numbers of radiation directions. So it is complex, and it will, I mean, the two loudspeakers, if you have a stereophonic, two-channel stereophonic setup, they will do most things together, so they will work together, and they will always also be influenced by the room. So it's an interesting question. Where do the room begin and where do the loudspeaker end?
Here I must clarify for the listeners that when Ingvar is talking about basic knowledge in physics and mathematics, he's still talking about a level way beyond most of us.
Well, I don't know. I don't
We
know.
know.
Yeah, okay. Well, it's simple Newtonian physics, if I put it that way. You don't have to even open an Einsteinian book to understand loudspeakers. They're not that complicated. And the big problem, the big questions that you have to solve before you can make a perfect loudspeaker, which probably no one will ever do, is to have a 100% grasp of all the complexing factors, the stereo system, the room that the loudspeaker is working in, and of course human hearing. It's the combination of all these things that determines how well you can reproduce something. I had no intention at the time to be working with this later in life. I mean, a few years later, I started this in 1978. In 1983, I started working as an electronic engineer, designing geodetic measurement equipment. So I mean, music was a hobby, and reproduction was an important question, because so often it wasn't good enough. So that's basically my background.
And today?
The last 12 years, I've been spending most of my time designing home cinemas and recording studios. Very, very much high-end stuff. And I actually have done it in like 25 or 30 years, but the last 12 years I've been doing mostly that.
So you are a researcher and engineer and a sound engineer and speaker constructor and acoustic, what do you say?
I'm an acoustician.
Acoustician,
yeah,
okay.
But I'm not really a sound engineer. No, I mean, of course, as anyone interested in music, I've done a lot of recordings. Everyone probably have that has a pair of microphones. Actually, I've been doing a lot of research that is important for recording engineering, especially when it comes to acoustical documentation. Mostly few microphone recording techniques. But it has not ended up in me being working as a recording engineer, but as a lecturer for recording engineer students. So I've been doing that a lot. I think it's kind of important to have that component, because most people studying to be recording engineers, they don't have years and years to experiment. They are basically taught what is already known. But I think that there are so much more to do regarding recordings. So experimenting is really good. It's still a very flawed system to take this super complex reality and then pushing it down to one-dimensional channels, right and left channel that only varies in amplitude, creating frequencies and transients and everything. And people tend to see the audio chain as a chain consisting of different transfer function blocks, but it's not. I would say it's not really true, because at least the microphone setup and the loudspeaker setup, the start and the end of the chain, is rather to be considered as a encoding system and a decoding system, because you go from a very complex three-dimensional full information, full reality to this two-channel, two-dimensional chain, and then when you come to the loudspeakers, you try to recreate this original event. And actually, and this is really to a very high degree where psychoacoustics come in, trying to reproduce the event in a physical manner without knowledge of human hearing, it's doomed to be unsuccessful, because it's not possible. You have only two signals. You cannot, no matter how you try to use them, you can't recreate the original three-dimensional sound field, very complex sound field. But if you know a lot about how human hearing works and how we as listeners in the original sound field interpret the sound field, it's much easier to understand which sound field the loudspeaker must reproduce to be inexchangeable, or as close as possible to the original event. So yeah, psychoacoustics is very, very important.
We started this podcast and the website and everything because we think there is a big sound quality problem around the world. And when I told some friends of mine that we're going to do these podcasts and everything, they sort of reacted, problem? What problem? I don't recognize any problem. What do you mean by problem?
Right. True. It's not always that existing problems are recognized by everyone. Even people suffering from the problems does not always recognize the problems. That is true. Doesn't mean that it doesn't mean anything for everyone. But you should always listen to people who are concerned, the people who cares, even when they are a minority.
Why?
Well, because that even if a large majority are satisfied with something quite mediocre, and they don't recognize that there is a problem, if you listen to the people who cares, maybe a minority, and change quality of things, then quite often you see that also the majority notice the improvements. It's beneficial for everyone.
And if they don't notice any improvement?
Well, that's not a problem.
There's not a problem for somebody who doesn't care about anything. Yeah. It doesn't matter if things get better.
Right, exactly. It doesn't matter.
There's no threat.
But I mean, I think that most people who have spent time researching these things notice that everyone notices the improvements, even people who did not recognize the problems to start with.
But normally in everyday life, you're maybe not aware of these things, but if you really check them up, you can see that everybody benefits from improvement.
Sure. And when things are getting worse and worse over time, but slowly enough, most people do not react. I mean, look at what happened with telephone sound quality. If you had an old analog telephone in the 60s, sometimes, not always, but sometimes the sound quality was amazing. And then it was gradually less and less good. Everything was digitized, and then came mobile phones with lesser and lesser information speed, and the sound quality got worse and worse and worse. And we ended up with a situation where people started to say, is the sound quality not good? Which is so weird, because if you let them listen to something that you could hear over the phone 30 years earlier, where you can actually hear what someone said 10 meters away from the telephone at the same time as you listen to the one you're listening to. I mean, people are shocked about the quality that was present and that now is lost. So,
but that's always a problem with sound. Sound is so sort of short. You can't really, for example, if you're looking at two TV screens, you can easily look at them near the same time and compare the two pictures. You can see which one is the best or anything. But in sound, that's always very difficult to compare.
Yeah, well, if you can make a real comparison, then actually you can do it quite well with sound as well. But the problem, I think, is that it's so much more difficult to compare with something of the past, because we are really bad statistically in remembering sound experiences. We may remember how we felt by the sound, but we seldomly remember. I mean, if you look at a movie, someone goes to a cinema and sees a film, or a movie theater in America, and after the film, everyone remembers the film regarding what they have seen, but not many has noticed how the sound is created, which music was used in the film. But I can assure you that if other music would have been used, you would have a totally different impression of the film.
And maybe a totally different memory of what it was all about.
Yeah, a totally different memory of what someone you saw on the screen felt.
Yeah.
Even though the picture is identical and only the music is different, but still. So music is very difficult to remember, but it's very powerful in communicating feelings.
So what is the problem today?
Regarding this?
Yeah, sound quality problems.
I think the big problem is the consequences of loudness war that has been rising the last 20 years or so, maybe even 30. Depends on how you see it.
Yeah, but you can say that the loudness war is very much a result of radio stations trying to get out as loud as possible, because this is a good signal. I can hear everything on this radio station. But nowadays, music is distributed in so many ways, through the internet, the web, the mobile phone, everything in digital domain. So why are we still having the loudness war then?
Oh, that's very easy to explain. But I think we should talk about one more thing first, and that is that it is very easy to make different versions. High dynamic version, low dynamic versions. But it is very clear today that the record companies do not want to do different versions. They want to have one version. And that, of course, is a big part of the problem. And that, of course, is a matter of education or time to think about the potential. I don't say that they are wrong, but since, as Lasse says, it's not really a problem to give many different versions, and it would apply. It would attract the minority again. Maybe not the majority, but the minority that really cares would be very happy. So I think that if that was just clear for everyone, then there should be a lot of not heavily mastered versions of a lot of music.
But you have different kind of versions in now. We have a
a
GG version, a radio version. So you have 3-4 versions if you check the internet music service. You can find,
but mostly not concerning levels.
No.
It mostly concerns
the mix, the different kind of
the
mix,
and
yes.
the length and everything of tunes.
But it's not as common as it was. In the 80s and 90s, there were always radio mixes with really adapted to be transmitted via radio. Now it's not that common, and most radio stations use the normal CD version or something.
But why is there a problem that things get louder? We can hear them better.
No, it's a big problem, because anyone who would like to make something dynamic will have a very low medium level, and that's the impression that you get if you jump between different radio stations or different songs or different whatever. The one with high sound quality will be very weak in level, because people who compress the music heavily, I'm not talking about data reduction now, dynamic compression. They aim at being at peak level all the time, being very loud. So it's not a problem for people who compresses. It's a problem for people who don't want to, that they
will be rejected by radio stations, and they will not be heard in your mobile phone or anything else.
Yes.
Because everything is regulated with this loudness war peak maximation all the time.
Yeah. You can say that without regulation, there will still be regulation, because there is nothing more than peak level. You can't have anything more than peak level. So without a system that people have been spending time doing as good as possible, we will only have the peak level, and the one that aims at being at peak level all the time will win.
But it was strange, because there is regulations on DAB, on DVB, on music services, Spotify and so on. It's very strange, because ITU has regulation. It's very clear, but why don't they use it?
No radio station would like to be the first one, because then they lose on the ether instead.
Yeah, but
Things are happening
I
now.
still want to know, why is there a problem that with sound quality if you make things louder?
You have to reduce the transients.
Oh,
And if you take FM stations, you have no headroom on the treble. You have a preemphasis, and they don't use the preemphasis. Had to reduce the transients for the treble. There's a lot of 14, 15 dB down, together with maybe 6 dB limiting. So you have 18 dB reduce the treble transients.
so when you sort of lift up the level of everything, it's not just the level that affects.
No.
You have to add a compressor, because the peak level is unchanged. You cannot go beyond peak level.
No.
So if you want to be very loud all the time, you have to destroy the dynamics and compress the hell out of everything, basically.
And no overshoots is allowed. So you had to clip the sound in more or less clever way. But you had to clip, otherwise you have a pumping effect of the limiter. So you have to clip the sound in even in the treble. This is very, very difficult to do that. This is a new culture, how you go to do that without artifacts.
And that's happening today before the material gets to a radio station. Already in the production chain, you sort of start to...
Almost always.
Oh yes, but you can do it in the transmitting station also. So it's more control on the sound if you do it on the transmitter.
But it's also a big difference between different genres. If you see jazz music or folk music or classical music, it's not so much loudness war going on. But the big hits and the popular music overall is almost always...
It is definitely the pop and rock music world, or the commercial music world, that really loves these flat sausages. If you look at the
graphic
the
representation
optical
of,
print,
of a fine music
then
file.
you will have a flat sausage if you take away all the dynamic.
It has been reactions from even from mastering technicians that it's all gone too far. They have acted to sort of reduce this insane max leveling all the time. But so
they can't do much, because they are pressured from everywhere. I mean, it's very easy to blame the mastering technicians, because they have been marketing the idea of being the perfect source to make these flat sausages. They don't say it like that. But actually, it is the mastering engineers that has been the whistleblowers and saying that this has gone too far. We have to do something. So basically, they are the heroes. They are the ones who has.
But the CD media is going down. It's much more common to listen to the music services, Apple and so on, and this is going to change the situation for the future. Absolutely. When you compare two recordings, and one recording is much better, and the transient is there. why are you going to reduce the transients in the mastering? There's no way to do that.
Don't you think you're a bit optimistic now? Just because the tools are available, the standards
No,
are there?
I don't think so. Because more people, they are going to use. More and more people are using playlists. I think Spotify have 40% now of playlist, and when you listen to the playlist, you want to have the same average level. Therefore, I think this is going to change the world. The playlists are going to change it.
That doesn't have to change the way you produce your music.
But for the future, because why are you going to produce something whose sounds very, very bad? Why?
But Lars, you're very optimistic that the new standards today available for measuring sound levels, agreed by ITU and EBU, the big organizations, resulting in ITU 1770 and EBU R128.
Yeah.
That sort of change from looking at peak level to regulate the average level of material. You think this is going to solve most of the problem of loudness war?
Yeah, absolutely. Because I have since I think it's 1 or 2 months, Spotify is using minus 23 dB LUFS. And if you use that and to hear very, very different kind of music in a playlist, you can use it for hours, and it's absolutely a new thing. When you have heard that for the first time, you can't do it in another way. I promise, it's absolutely a new experience. I promise.
But it's very tricky.
Yeah,
it's a very tricky question that you asked.
Yeah.
If R128 will solve every problem, it depends on what you define as the problem. We should not have the standard to force people making high dynamic material, but the purpose of the standard is that the listener won't have to change the volume setting all the time, and also that people who wants to make dynamic material has the creative freedom to do it.
And has the possibility to be heard even if they have a high dynamic.
Yes. You have a headroom.
But could you shortly explain what R128 is?
Well, basically, you can always make an average. If you listen to a song that is 1 minute long or 5 minutes long, it doesn't matter. You can look at the average level. And instead of comparing the average level between that song and another song, you can make a psychoacoustically improved average level. And that basically means that you look at the song, you cut away silent parts, because that would make a false dynamic, and you make a weighing curve, the K weighing curve, that listens less to the bass and a little bit more to high frequencies. And then you compare the two songs and say that the average level is the same after adjustment. So, and that average level, according to R128, should be minus 23 dB compared to peak level. So basically that's the thing. So if you want to do program material that has a crest factor of 0 dB, a square wave, continuous square wave, you can do that. You can do it, but it will be.
It's allowed to do that.
Yeah, but it will be not strong in level. It will maintain the same.
It will be perceived as the same level as high dynamic material.
Yes.
Okay.
The same LU or LK.
Yeah. And the standards actually correlate to our hearing.
Well,
that's the trick, isn't it?
It really doesn't, but it tries to.
It's
not optimal. I think the weighing curve should have a peak at 3 to 4K because we are very sensitive there, and so this makes it possible for producers to want to be heard more, to add energy in that level, and it will not hit them as hard as if they would do it with a peak. But
I think it's a good compromise.
Yeah, it's a good compromise. Yeah. K weighing.
So talking about loudness war, that actually is the really big problem today. we may see some light in a tunnel somewhere over there, but it can't be. The loudness war is not the only problem, is it?
No, there's a lot of other problems also. But the equipment now is so much better than earlier. As you have headroom, you have frequency response, you have dynamics. It's not problems today to do that, but you have to handle the equipment absolutely.
Yeah, but if you listen to commercial music, and that, by that I mean the big hits, the big selling music around the world, I would say I can hear other problems. Lack of deep bass, a very high level in the frequency area where we are sensitive, around 3-4K, and a very high pushed up treble that makes it nearly impossible to play it loud if you want to, because it hurts in your...
But actually that's a problem that is related to loudness war, because the consequence, if you have only a peak level and you want to push up energy in every available frequency to make it as sounding as loud as possible, is that you will have much too much treble, you will have much too much distortion, and you can't have the bass levels that maybe would have been more appropriate for the music. So it's at least in part it's the same thing, but it's also caused by bad control room listening, weird standards, and the idea that music should be produced for being listened to in very poor quality hi-fi setups. So
I think
there are many different problems.
One of the problems is that the analog equipment, as typical microphone amplifier, they have not enough headroom there. In the 70s, you have up to 28 dB headroom in the mic amplifier. Nowadays you have maybe 18 dB. It's not enough when you produce. So the mic amplifier is going to clip, or you have an analog limiter before the A to D converter. Then you have a lot of problems, and it's a knowledge here. People couldn't handle the equipment.
But too little knowledge and too much anti-knowledge. I mean, it's even the case that recording engineers are schooled to use a limiter during recording, and they're told, well, you're going to add compressors and limiters later anyway, so let's do it right away. So an undistorted
more culture. The culture is more than that than the equipment. You can put the equipment in another way, and then you have an extremely good resolution and headroom and sound quality.
Better culture would be really good.
Yeah,
learning, teaching everyone that you can always destroy later. You don't have to start destroying, because you can never undestroy the things that are destroyed before the AD converter. At least it's very, very
you
difficult.
can buy very, very cheap equipment, and the mic amplifier is marvelous today. It's fantastic. You can do everything
at a very low cost, actually.
Low cost.
You have a production studio in your computer that would correspond to billions of dollars in the analog world.
They have a resolution and the sound quality. Everything is very, very good today. There's no problems.
Yeah.
Well, we have a problem.
Yeah, we have problems in the end, but I think it's more education.
I happened to encounter a very famous technician, sound engineer, actually, on a boat in the Stockholm archipelago, Bruce Vedin, who was sound engineer on most of Michael Jackson's records, for example. He has been working very much with Quincy Jones and so forth. And of course, he was there, so we started to discuss sound in different matters, and he was, at least then, of the opinion that a reason for all these strange artifacts in producing music is that very few sound engineers today had reference in real sound. They never heard a drum directly, acoustical. they always heard it through a microphone, a cable, and a control room and monitors and everything. That people working in sound production today, he said, has too little reference to real sounds. What do you think about that statement?
That is true, but it's difficult to know how big a problem it is. If you have an idea on what you want to create, maybe you can do it via the control room. I think the quality of the control room is a bigger problem, but it depends on the genre. I mean, if you're recording acoustic music, maybe it's more important to listen to the actual sound, because it's more of a documentation to make that kind of recording. I have myself an experience with a big Swedish test of many different microphones, and Semir Lazarov from the Stockholm Symphonic Orchestra was there to play his violin, and a lot of different recording engineers was there to judge the sound quality of different mics. And to my big surprise, I was the only one in the recording room listening to Semir playing music before I went up in the control room to listen to the results via the tape. The tape, of course, was digital then. And so I just asked everyone there why they didn't listen to Semir first. Because how can you judge the quality of the microphone if you don't know the source? And they looked at each other and looked very surprised, and they have never thought of actually listen to the original music. So weird.
Yeah, but shouldn't that be obvious? If you want to test a microphone, you need to know what sound reached the microphone to know how the microphone handles.
Sure.
Isn't that obvious, or?
Yeah, I think it is. I mean, even much more obvious than if you would make a recording. Maybe if you make a recording with Semir, you care about how the violin sounds on the recording. But if you want to judge the microphone,
test the microphone.
You want to get to know the microphone. You want to learn about how its characteristics, and of course you have to listen to the acoustic sound to do that. Now the control room loudspeakers wasn't all that good anyway, so but still, it is so strange that people are losing contact with original acoustic sounds.
Well,
it's weird.
That's happened also to me once. I was a sound engineer on a festival with different folk music bands in Stockholm, and one of the very famous trios of Sweden, playing two violins and a viola. We were having a sound check on that concert, and I went up to them on stage and I asked them to play a bit. And I asked them to play because I wanted to know how their instruments sounded acoustically and how they balanced their sort of different parts together. So I had something to sort of start with working as the PA sound engineer. And I asked them, can you play a little so I can listen? Yes, they said. And they looked at me very strange because I stood there at the stage.
Yeah.
And I said again, can you please play? Yes, of course, they said. And they looked at me again. And I say,
no.
Could you please play? And say, oh, you mean now? Yes. Oh. And they started to play acoustically so I could hear their instruments and how they balanced and everything. And then I went back to the mixing console, because now I knew what I had to work with, and I could do everything I want, but I wanted to know how they sort of how they balance their own music and how the instruments sound. And the strange thing was, they told me they'd been touring all around the world for 30 years. They're experienced, extremely skilled musicians. They said it has never ever happened before that some sound engineer wanted to hear their actual acoustic sound prior to microphones and mixer and speakers and everything.
Yeah, well, it was a very odd sound check that you that you performed. So I understand that they are surprised, but everyone should be odd like that.
Yeah, I think if you have a group playing together acoustically, of course you have to listen how they want it to sound when they're controlling it themselves. Then you can, of course, do what you want to get it sounding well in the room or arena you are using it. But knowing what you have to work with, what you have as a material make it more easy to actually get to the point where you're satisfied with the sound.
Yeah.
And you said it's also by monitor problems in the production chain.
Yeah, well, there are many different problems. As I said, I think after the musical production is done according to musicians and producer, hopefully without thinking about commercial aspects at all, typically the music goes through mastering, potentially feedback from the radio who wants it to be even harder compressed, and then the last problem is the hi-fi equipment that people have at their homes that also will change the experience of the music. And well, actually this sounds like three links: mastering, radio and hi-fi equipment, but there is a fourth link, and that is that the result that producer and musician accomplish is heavily depending on what they hear when they work. So control rooms are very different, and on top of that, it has been an idea that has been popularized through the years that you should never produce music for people with good setups at home. You should produce it for the crappiest hi-fi.
But what do you know about the crappiest? How could you judge what?
Well, you really can't. I mean, of course you can say that most of the crappy hi-fi has a less extension in the bass, which is not true if it is headphones. Not necessarily, at least. And maybe you can say that in many cases you don't have all that much peak level, acoustic peak level. Mobile equipment has regulations regarding how loud, which is really sad that it regulates the maximum level, not the medium level. And that means that if you want to be able to play loud enough, you can't have this dynamics that our 128 let us have, because the machinery has been adapted through the years, the last 20 years, and regulations have been added to save people's ears, not in an intelligent way, because there is an idea in audiological circles that transient sounds are very dangerous, and it's a misunderstanding. It's kind of a humanistic interpretation of the technical factor or data. The fact is that you can listen to transient at much higher levels than static sounds without destroying the ears. But it's also a fact that the most destructive sounds for the ears are transients. But it's not because they are transients, it's because they are very loud. So regulating maximum level, that actually adds to medium level if the result is compression, and that is dangerous for the ears. It would have been much better to maintain a high peak level, because musical transients are not dangerous, they are just good. But it was easier to regulate maximum output of mobile equipment.
So that really means that if you try to listen to dynamic music through your mobile phone today,
yes,
the regulations make it sound weak.
That could be the case. I mean, of course, it's such a strange thing to regulate the peak level, because it doesn't say much, because the headphone may have very different headphones have very different sensitivities. So some you can still play it pretty loud. It's just a stupid way to regulate it, to set a maximum level in voltage. It's not well thought through, but that's the way it has been done.
But that will be changed in some years, I think.
I really hope it will. Yeah.
Mm-hmm.
Really
You're the
hope so.
big optimist in this
Yeah,
trio.
yeah, because you can hear, if you take old material for I can take Spotify and use it in the playlist. It's marvelous to hear the difference between old material with transients and new material who is very compressed and limited. If the older material sounds much better in the playlist, and that is going to be a new reference.
You're very optimistic. I wish I was as optimistic, but I can, at the same time as I agree totally with your experience regarding old material, I can see that Spotify is taking away the old masterings and only keep the late masterings with heavy compression and high. So they're working in the absolute
Do you think it's Spotify? Is it a gramophone
No, it's not
company?
the gramophone company.
The gramophone company, I think, because you can hear
The
you
music
can found
companies.
But it's really sad.
France Gall,
Oui?
and I found, I think it was 30 different versions.
Oh yeah. I found a lot of different versions, and later I found that some of them are removed.
Okay.
But on the other hand, one of the big things that happened in all this loudness war was when Metallica released a new CD, and by accident there was the same music in a non-mastered version out with
You're talking about Guitar Hero.
Guitar
Yeah,
Hero.
yeah, absolutely.
And
They sent the non-mastered version,
but,
yes.
But it wasn't three old humps like us who reacted. It was
No,
all the
the kids.
Metallica fans
Yes.
Yeah.
who bought the Guitar Hero version because
Yeah.
it sounded so much better.
Yeah.
And I think it was about 10,000 fans
Yes.
who wrote to the record company and said, please take away that CD version and do and make a new CD with the Guitar Hero version instead, because it sounds so much better.
Yeah.
That was, in a way, the start of starting to
Yeah,
question
you
the
have
loudness
right.
war.
Absolutely, that's what the point. The point.
And that was not three grumpy old men. It was all the fans of
Lot-
Metallica
a lot
that
of fans.
actually noticed that this
Yeah.
sounds much better.
I would like to remind you all what I said in the beginning, that we should always listen to the minority that cares, because the majority that may not care or believe they care, they still may hear the difference.
Mhm.
And I think this is a superb example. No one complains about the Metallica CDs until they get a chance to hear what they could have heard.
I think a lot of people can hear that. We have done a
Sure,
lot
everyone,
of listening
everybody.
tests, and everyone can hear that if you really want to test that. I promise. But
If
they
you-
are not
yeah.
interested. But there's another thing.
But you have to also have the chance to compare.
Yeah.
And that's a problem. Because if Beyonce makes a new record, you get one version. You couldn't really imagine how it would sound like if it was produced in another way.
No.
I would say that a chance to compare is not enough. It has to be a fair chance. And what I mean is that typically, if you're a musician or a producer or something like that, and you listen to pre-mastering and after mastering, and you compare them, you will hear the mastered version, because it's compressed, much higher, much louder. So, and that's not a fair comparison, because especially if you really apply R128, they will be listened to at the same level, same medium level, same LK or LU level, LU basically. So I think I've done a lot of comparisons like this with unmastered and mastered music. Of course, I should say that there are examples of music that has not been mastered that sounds terrible. I mean, mastering engineers do not only massacre the dynamic, quite often they save recordings as well. So you have to use some material that is well produced before mastering, of course, to make this comparison. And then you have the mastered version, perhaps a CD that has been published and sold, and I have the tape from the studio, and I can make a comparison, and I can adjust the levels. And I've done that many times, and so far I've found no one preferring the mastered version.
And then you're speaking about the musicians who actually play the record.
Yes. The musicians has been a part of the process, and they have been talked into that the mastered version is better, and they have heard without any level matching, so that the mastered version is much louder and they like it. And then when they have the chance to listen to them at the same level, they change opinion to the absolute opposite.
Actually, we humans, if you raise the level a little bit, even 1 or 1.5 decibel, it sounds better, isn't it so?
You have
Quite
to
often,
compare
yes.
it to
Quite often.
two different kind of levels.
Yeah.
Yeah, you
We
prefer.
like a higher level.
Yeah, you prefer.
And that's not imagination, it's actually true.
prefer the-
It sounds better.
Well,
frequency response is a little better.
up
than,
to a level, it is true.
Yeah.
But I
But
mean,
not
if it is a little
mechanically.
too loud, it sounds better when you take it down a little bit.
Okay.
But yeah, it depends. But yeah, it's quite common that if you want to make version B to be preferred to version A, play B a little bit louder. Yes.
Yeah. But now, talking about the different problems that we actually are gonna address in upcoming podcasts, we have the loudness war, the big problem. We have also problems with lack of reference of how sounds actually sound in the real world.
Yeah.
And
Which is the first problem in the chain.
yeah, and then we have the sort of last problem, the monitoring, the
No. That's the same thing.
Yeah, okay,
Let me try.
yeah,
Sorry.
yeah,
Sorry about that. I would say that the first problem is the lack of reference, and that includes that people do not listen to sources directly, and it includes that they don't know what they're hearing in the control room because the quality is not good enough. I think that's the first problem. The second problem is the effects of loudness war, which is often crazy mastering, reduced dynamic levels. I think the third problem is the fact that this is added to by feedback from radio stations that wants to have high medium levels, not many dynamics. And the fourth problem, I think, is the hi-fi equipment that people have in their homes. And then I said 1, 2, 3, 4 based on in which order they comes in the chain.
And nowadays, when many people listen through their mobile phone, there's also a problem that levels in the mobile phone are regulated to protect your ears,
Sure.
but in a not very smart way.
Yeah, sure. That's another part of the fourth problem. Yes, absolutely. And it's caused by the loudness war and lack of knowledge regarding what dangerous sound is. It's not smart to regulate the maximum level to protect the ears. It's the exposure that is the problematic thing.
You had to mention also the bit reduction system and pod is
Yeah, that's also
yeah.
that's also a big
Why
problem.
on pod 128 kilobit per second is very, very strange. You can have it in PCM or higher bit rate, or the TV stations use a lot of higher bit rates. Why are sounds so low bit rate?
And it's actually getting to be even lower. People are working hard to push it down even to lower bit rates. It's so weird when wide bands are getting better and better and memory banks are bigger and bigger. I mean, many years ago, the argument was that 128, that's a proper speed because then you can have enough songs on your little pin.
Yeah, but that's also the economic reason for distributing. You play less surf charges, or you have better space on your hard disk or anything. You can keep 1 million songs instead of 1,000.
It's always in that way, but the quality.
Yeah, the
But
quality is.
Something is weird. I mean, I can understand that you can argue that 1,000 songs is better than 100 songs. But is really 10 million songs better than 5 million songs? Is it a point? when you have so much storage,
Yeah.
that it's I don't know.
But all the music services are using much higher bitrate. Tidal is using PCM or FLAC or
Yeah, the streaming services.
the streaming
has
service
gone
no
up. Yeah,
problem
no.
today. It's a pod.
Yeah.
Yeah.
Why are pod so low?
Podcasting is nearly always in. You can actually compare this podcast because at our homepage you can find it in linear PCM version and in lossless FLAC version, but also in the 128 MP3s. And I think if you have a fair listening possibility,
Yeah.
it's easy to hear even what this low bit rates affect speech
Yeah.
that you think is a simple signal, but it isn't, because you have all these sounds that's hard to encode with low bit rate MP3s.
Depends on what kind of voice.
Yeah.
Some voices are more sensitive for that.
It also depends on the generation of the encoder.
Yeah,
I think it's very interesting because the early 128 less advanced codings, they typically sounded better. You lost some top end.
Yeah, because
wasn't-
they reduce the top end
Yeah.
of the new version.
Yeah, and the more advanced decoders, you try to recreate something and you make advanced algorithms. It becomes worse.
The same problem with the DAB plus low bitrate. Why?
Yeah, but that's also been the aim in research in many years, not to sort of improve transparency on lossy encoding, but to get it less lousy at the same low bit rate. That has been the aim, I think.
Yeah.
Yeah.
Yeah, and there's not actually a problem, because throughout the world today, broadband facilities
Yeah.
that are getting more and more widespread all the time. Data storage equipment is cheaper. You pay hardly nothing for a big fat memory today than you did 10 years ago or even 2 years ago. The prices are going down. And at the same time, you take your mobile phone and you look at videos that
High bitrate.
had much higher bit rate than even a linear PCM distributed.
Yeah, no problem.
So there's actually no need for this.
No.
Oh, I don't know. It's always a sum of everything, and basically, it's a matter of discriminating on sound. It's not seen as important as video, so they think that even though the soundtrack takes much lesser space than the video, as long as you can save a little bit, you can make more video.
Of course.
So it's always this balance, and it's kind of weird.
There's no need today.
I think to a high degree it's a matter of attitude, and I think that you can approach almost any problems with one of three questions. You can ask, how good can we make this? Or you can ask, how good do we have to make this? Or you can ask, how bad can we make this?
And still
Get away with
get
it.
away with it.
Yeah, and I think much too often, especially when it comes to sound, people tend to ask, how bad can we make that without causing problems, without having rejects, without having complaints, when they maybe should ask, how good does it have to be, or even how good can we make it? That would be the nicest, of course.
So now, trying to define the problem of sound quality today, we found that there's not one problem, there are several problems, and it's very complex, but we could still sort of define some sort of the loudness war, the lack of reference, lossy encoding, and lack of knowledge and skills as well. Lack of education, maybe. So, in our next pod, we will start with the end of the chain, so to speak, the control room. The monitor listening, one of the most crucial elements in music and sound production. Remember also to keep an eye on Ino-Lab.com, where there will be more specific videos presented, digging deeper into each subject. And mail your questions to ask@ino-lab.com.